All right, thanks, Dan, for the introduction. So today we're going to be talking about the use of this composite parameter that we actually discovered during one of our post-mortem event reviews from actually a pretty surprising tornado outbreak we had last fall. Coming up to the 1-year anniversary of it actually in about 9 days.
Doug, you're muted.
Oh,
I can hear you now.
okay. There we go. Okay, so brief outline of the event of the presentation. I'm going to give a brief overview followed by the SPC forecast progression, showing some satellite and radar imagery from the event, some mesoscale analysis, finally an introduction to the MOSH parameter, and more recently utilizing the MOSH into AWIPs for future high shear low CAPE events. So some quick facts for the event. So we had a high shear low CAPE environment across the northern Ohio Valley on October 21st of last year. The environment was favorable for several embedded low top supercells, similar to actually what some of the region might experience today, which I'll go into near the end of the presentation. We had 8 weak tornadoes across the area, 4 of which were EF1, 4 of which were EF0, so relatively weak, short path length, very small width tornadoes owing to the very marginal environment. All tornadoes generally occurred in the afternoon and early evening, and there were 0 injuries during the course of the event. So here's the low-level MRMS rotational tracks across the area, just to sort of give you an idea of get everyone thinking about where these tornadoes may have occurred. As you can see, there is some higher values of these low-level rotational tracks, which extend into the Pittsburgh area of Western Pennsylvania. So here's the LSR map, SPC LSR map from October 21st, showing the event starting in our area and transitioning into Pittsburgh's area through the course of the afternoon and evening. So once again, we'll revisit the low-level rotational MRMS tracks. And these 3 areas are what we'll focus on for our area, at least. That's where the bulk of the tornadic storms occurred. So what about the forecast? So even though the potential for severe weather was apparent even on day 3, with SPC outlining the region in a day 3 marginal risk and maintaining that risk throughout the event, there was never any mention for any possibility of any tornadic storms. So here's the day 3 outlook showing that marginal area across northeast PA, northeast Ohio into northwest PA and western PA. In the discussion, they did mention corridor, very narrow corridor of mid-50 dew points, low-topped convection, strong unidirectional southwesterly winds, and the overall threat should remain limited because of the limited instability. Day 2, maintaining that marginal risk with just a 5% damaging wind threat. Very similar discussion for day 2. And on day 1, they did expand the marginal risk south into the southeast U.S., still maintaining that 5% wind, 0% TOR on the right. Now, in the day 1 discussion, there was a couple of sentences which did mention an isolated supersonic cannot be ruled out, but that the instability, limited instability, will be what the limiting factor for the severe weather coverage across the area. Now, by the 20Z update, the event was ongoing in our area. SPC did introduce a 2% TOR downstream into the Pittsburgh area. And here's that discussion, just talking about the addition of the small 2% tornado probability area. Mentioning now that the low-level wind profiles do supports some organized rotating updrafts, which we'll also see in a reconstructed photograph later in the presentation. So now we'll go on to the satellite imagery. So first I'm showing the air mass RGB product, which is an RGB satellite product, which has contributions from 3 other single bands, those single bands being the 3 different water vapor loops, the low, the upper, and the mid water vapor. So one thing I like looking at the air mass RGB, it's actually in my day-to-day situational awareness satellite display. It gives you a nice broad view of the different weather patterns across the U.S. without actually looking at any radar or observations, surface observations. So in this case, I'm using the air mass RGB to sort of diagnose where there's better mid to upper level moisture across the area. So while I have the white oval across much of Ohio, you're getting those blue colors ahead of a deepening low pressure across central Michigan, noting that you do have some continuity, especially in the mid to upper level water vapor contributions, which are in the bottom 2 panels of this 4-panel. In addition, you can perhaps see some high potential vorticity air, at least initially, as the low tracks east across Michigan. So another one of my favorite products that I use, especially in the convective, but also the winter season, is the day cloud phase distinction RGB satellite product. Now this satellite product has contributions from 3 different GOES single bands, those being the clean IR band for the red contributions, the red visible for the green contributions, and then the snow ice band for the blue contributions. Now I mentioned I do use this in the winter as well, because we do get lake effect snow as well as very rarely snow squalls, but both of which are convective in nature, and this product can help, especially where radar coverage is more limited across Northeast Ohio into Northwest PA, can help sort of fill those gaps. Now in this loop, you'll sort of see the entire evolution of what became the tornadic line across the area. So you start to get those more agitated Q, starting to get to some of those bluish green colors, and then you're becoming fully glaciated is when you're getting those green colors. And then finally into the mature stage, when you're starting to get those overshooting tops and getting close to those cooler cloud tops and those yellow and red colors near the end of the loop. So now we'll go through a couple of still images from the event. So starting at 2:30. So a couple of things actually I wanted to note before we go into the day cloud phase distinction is this sort of clearing behind. We did have some morning convection off to the east, which you can kind of see in the day cloud phase distinction product. We did have a brief clearing, a couple hours, which allowed the instability to actually overachieve what some of the models were suggesting. In the top left image, you can sort of see these feeder cumulus clouds coming south to north into right ahead of the cold front. And that was the first sign potentially that, maybe we didn't have unidirectional southwesterly flow across the entire column. And that maybe in the lowest levels, which we will find later in this presentation, is what contributed to some of these low top supercells and tornadoes. So by 3:30, you can sort of note, our line is becoming much more mature. When you look at the top right image, that's the cloud IR, that long wave IR image. You're starting to get colder cloud tops in the realm of -25 to -30. And then finally, by 4:30, this is the time of our first tornado report, just south of Cleveland in Medina County. And it's worth noting that now the cloud top temperatures are in excess of -40. So when I do use this day cloud phase distinction satellite product, I use it in conjunction with the IR satellite product as well, just to sort of diagnose some of those cloud top temperatures. Whereas for the day cloud phase distinction product, I really like that for initiation, especially in the convective season. So now we'll sort of go into some lightning products via the GLM. So I overlaid all the tornado reports in our area for this case. Now, at least in our area, the GLM, looking at these loops, did not seem to provide that much utility. You could argue that there was a brief signal, especially just south and east of the Cleveland area. But again, these signals were very sporadic and very brief. And this is also shown. That in that our tornado reports were all less than 10 minutes in length. They've had very small width, all EF0, all EF1. So the very marginal environment. Well, when you look in Pittsburgh's area, they didn't have, I don't believe they had anything stronger than an EF1. There were a few more consistent signals in the GLM, both in the flash extent density and in the minimum flash area, which is shown on the bottom. It's worth noting that I do use in my procedures the flash extent density in addition to the minimum flash area. Minimum flash area more to sort of see where those smaller new updrafts are in relation to some of those larger flashes, which may suggest a more mature and weakening storm. Now, total optical energy in the top right, I've been still trying to find some utility for that, but it seems like you could get a lot of false alarm with that product if used by itself. So now we're going to the radar for that first tornado. Note how fast it sort of came together, but also dissipated. So in the top left, you have the reflectivity. Top right is velocity, storm relative velocity. Bottom left, you have the correlation coefficient. So note that brief drop in CC. Some of our CC wells seem to be a little exaggerated, but perhaps because it was the fall and maybe it was picking up some additional leaves as well. And then the bottom right is the low-level MRMS rotational track, which I also like to use in terms of situational awareness. So this is a reconstructed hodograph I used from the level 3 Cleveland radar files. I looked back at the surface obs and came out to have a southerly wind around 10 knots. So you can sort of see in this hodograph, things get pretty messy above 3 kilometers. But below 3 kilometers, you have a nice clockwise turning hodograph here, which did result in some effective SRH in the 0 to 500, around 75 to 100, and perhaps up to 125 as you get up to 0 to 1 kilometer. So all low-level rotational driven. Here's a larger image for reference. So sort of showing that that low-level 0 to 3 curvature, and getting a little more messy as you get higher in the atmosphere, which is what you would expect in an environment like this. So here's the MOSH parameter that we discovered proved useful for this event. I'll talk a little more about it, but basically anything over 3, when you're starting to get to those pinks and purples, purple colors, is when you start to become very favorable for severe weather potential, not just tornado genesis, which I'll talk about. Here's a loop of the MOSH parameter throughout the course of the event, noting those higher than 3 values sort of being advected east ahead of the cold front. So the MOSH is derived from the SHRB-E, which is the severe hazards in environments with reduced buoyancy. The SHRB-E has 2 different equations. Basically, one is 0 to 3 kilometer shear, one's effective shear. You'll see this mid-level lapse rate, 700 to 500 millibars. In the MOSH, that's actually replaced with this max TEVV term, which is sort of like a composite max theta E difference in the low to mid levels. In addition, instead of the 0 to 3 kilometer shear, you're now in the 0 to 1.5 kilometer shear to sort of hone in on those lower topped events. And this graphic here is basically just showing that once you start to get above, so when you're looking at these null events, the highest is just over 3. So once you're starting to get higher than 3, a 3 value in the MOSH parameter, your environment starts to become very favorable if you have a storm. That's the caveat. If you have a storm, your environment will become favorable for any severe weather potential. But in this case, just looking at the photograph, we would probably expect to see wind and a brief tornado. So more recently, we were able to get the MOSH, not the MOSH-E, but the MOSH, so not the effective shear, because we can't get an effective shear in AWIPS for now. But we were able to get this in AWIPS for several different models, including the RAP, NAM, the FE3 cores, and the GFS. So this is just one example I pulled. Today would have been a much better example, I believe, especially for the lower Ohio Valley. If I have time, I'll show that in the SPC products. But this is the MOSH contours overlaid on top of the day cloud phase distinction product. So I think this could actually be very well utilized by a mesoanalysis position within the office, sort of tracking how that environment is changing, in addition to seeing how the environment is changing on the satellite as well, and how those clouds, like I said earlier, for the day cloud phase distinction, how I like to use that for initiation. And then overlaying that with the long wave IR to see the cloud tops and how rapid the cloud tops are cooling. Now it's important to note in AWIPS, this MOSH parameter will be zeroed out when the model CAPE, MU CAPE is less than 10 or higher than 2000, just because we wanted to focus more so on those lower instability scenarios with high shear. So we do have a local event summary for this case on our webpage, in addition to any other events that we've been starting to archive those on our webpage. So those are the links. And with that, I'll take any questions, but I do want to show, it looks like I do have maybe a couple minutes. I can show the MOSH parameter in the SPC mesoanalysis webpage. So it's under the beta parameters, and you can actually extrapolate this out up to 6 hours using the RAP. So as we go forth in time, you can sort of see those higher values actually associated with some radar model reflectivities. So it'll be interesting to see if there's any severe reports, whether that be damaging wind or tornadoes in the Ohio Valley region later this afternoon and evening. But that's one utility that you can use the MOSH for in the near term using the SPC mesoanalysis page. In addition to, if you're interested in having it in AWIPS, then we can help set that up for you. All right, I think that's all I have here. I'll take any questions.
Okay, any questions for Doug? Maybe give some people time to think about it. Let me ask a question here, Doug. When you showed that radar example, was that, it showed up pretty nicely, I should say, in terms of the signatures. Was that quite close to the radar, and were there other storms further from the radar that didn't show as good of a distinct signature?
Yeah, so this case was really interesting because almost every tornado one storm that we had exhibited as a CC well. And we actually had CC wells that were confined with velocity couplets that we couldn't find any damage for. So I don't know if that was because of, you know, the leaves on the ground, that it being fall, sort of exaggerating the CC wells. You know, I'm not sure, because we did have other CC wells that we couldn't find any damage with. But
Okay.
this specific storm was probably about, I don't know, maybe 40 miles south of the radar. So I would say all of the storms were probably 6,000 feet or less above ground level from the radar.
Okay. Okay, thanks for that comment. Any other questions for Doug from anybody else? You can put them in the chat window, or if you need me to unmute you, just let me know. Oh, I see a comment here from Joseph Patton. You briefly mentioned that TOE has been difficult to use in operations. In contrast, have you seen FED and MFA have a significant positive impact in warning decision making?
Yeah, thanks for that question, Joseph. Definitely the flash extent density, because I think that's probably the most known and trained with forecasters, especially having, you know, some of the Earth networks and NLDN data. But now we can have it in a gridded format, and I think you know, seeing especially those rapid increases or decreases in the flash extent density is probably the easiest to diagnose in warning operations. The minimum flash area is a little more difficult, just because it does seem a little more jumpy, at least with the color curve that I have. But I still try to have it up. And sometimes it does help, especially for some of these pulse type storms in the summer. Sort of seeing, you know, if you have a large flash, a lot of times then, you know, maybe 5-10 minutes later, the pulse storm will start to collapse. So maybe that's a utility. But for the total optical energy, it's been very hard, because you'll have a storm that maxes out the color scale, but you know, it doesn't really do much in terms of damage or even intensity.
Okay, thanks, Doug. Any last questions here before we end the webinar?
I can pull up one last thing. I do have this is the College of Duke page, but I have the air mass product for today's event. Pretty interesting dry contribution coming from the Pacific, sort of maybe enhancing some of this convection across the Tennessee Ohio Valley today. So sort of like a nice overall broad picture of the day's weather without actually looking at any radar or surface observations, like I mentioned earlier.
Right. Okay. Well, thanks, Doug. I don't see any other questions, so we want to thank you for today's great presentation. And remember that the recording will be available on the visit web pages fairly shortly. Thank you, everybody, and have a great day.
All right. Thank you.